Hey everyone, in this video we are going to talk about scientific notation. So go ahead and take notes alongside with me. What is scientific notation? It is a compact way of writing very large or very small numbers frequently used by scientists and mathematicians. So for example, the minimum distance from the Earth to Mars is approximately 284,000 miles. In scientific notation, that would be the number 2.84 times 10 to the fifth power. And the reason why is because in 284,000, the decimal, since it's a whole number, the decimal's in the back. And in scientific notation, you place the decimal so that you have a non-zero single digit in front of the decimal point. So we move this decimal so that there's a non-zero digit in front of the decimal point, and then you count how many loops you did in order to get to that point. And every time you loop, you are looping by a power of 10. So 10 to the fifth power, which is 1 with 5 zeros behind it, multiplied to 2.84 will make 284,000. Now it is a positive 5 because the number 284,000 is in the thousands. It is larger than 1. Therefore, it is multiplying to numbers that are in the thousands and numbers that are larger than 1. So when the number in standard form is larger than 1, you're dealing with positive exponents, because positive exponents on 10 are like 10 to the first, which is 10, 10 to the second, which is in the hundreds, 10 to the third, which is 1,000, and so on and so forth. Let's compare that to example 2. Example 2 says the 2004 Indonesian earthquake slowed the rotation of the earth, making the length of a day be 0.00000, I think I said enough zeros there, 268 seconds shorter. So in scientific notation, this would be 2.68 times 10 to the negative 6. Again, you need to move your decimal point so that you have a non-zero digit in front of the decimal, one non-zero digit in front of the decimal, and then you count 1, 2, 3, 4, 5, 6. And it is going to be 10 to the negative 6 rather than 10 to the positive 6, because 10 to the negative 6 indicates that the original number was a decimal that's smaller than 1. I'll say that again. The negative exponent indicates that the original number was a decimal smaller than 1. For example, 10 to the negative 1, well, that's 1/10, so that's a decimal. 10 to the negative 2, that's 1/100th, that's a decimal. 10 to the negative 3, that's 1/1000th, that's an even smaller decimal, and so on and so forth. So since this is in the super small decimal place, that should be indicating that you have a negative exponent. Okay? So you basically, by looking at the number, since this is in some form of hundreds, thousands, our exponents will be positive. Since this is in the decimals, our exponent will be negative. So go ahead and try some of these practice problems and check your answers on Canvas to confirm that you are able to write numbers in scientific notation or from scientific notation to standard form accurately. Again, check on Canvas your answers and mark any of the ones that give you a hard time. The next thing we're going to do is talk about something that might be new to you, which is adding and subtracting numbers that are in scientific notation. So in order to do this, we're going to follow 2 steps. The first step is we're going to make sure that the exponents are the same so that we can add or subtract them. In order to make sure the exponents are the same, we can use an acronym called LARS, which stands for left add, right subtract, to shift the decimal and change the exponent if needed. Then we add and subtract the numbers and keep the common exponents, because it's kind of like combining like terms. But we can't combine them if their exponents are different, So we fix the exponents first, and then we can combine the like terms. Let me show you what I mean by that. In this first example, they already have the same type of 10 power, or power of 10. So we can just combine them to say that there is 8.6 times 10 to the second. So 3.4 times 10 to the second plus 5.2 times 10 to the second is the same as 8.6 times 10 to the second. But in number 14, they don't have the same base 10, or they have the same base 10, but they don't have the same exponent. So we're gonna go ahead and I'll shift this one to a 7 power. So since I need to make this go up 1, left add, right subtract. So I'm going to move the decimal to the left so that I can go up 1. This is the same as 9.5 times 10 to the 7th plus 0.11 times 10 to the 7th. Left add, right subtract. So since I moved the decimal to the left, I was able to add up 1 exponent, add up an extra loop. Now I can combine the like terms, so I can add 9.5 plus 0.11 to give me 9.61 times 10 to the 7th power. Let's try another one. So for number 15, again, we do not have the same exponent on the tens. So in order to add them, those do need to be the same. So I'm going to go ahead and make this one become a -4. So I need to add 1 to this, which means I need to move this left 1, because left add, right subtract. So if I move the decimal on 3.18 left 1 to 0.318, that gives me 10 to the -5 plus 1, which is 10 to the -4. And then this is the same, obviously. Okay, so moved it left 1 so that I can add 1, left add, right subtract. And then I'm going to add those two together to get 7.558 plus 10 to the -4. So here what I'm thinking, or what you're probably thinking is, well, why did you choose this one and not this one to move? If I move this to become a -5 exponent, okay, I have to move to the right one, left add, right subtract, which will get this to be a double digit in front of the decimal point, and it'll get me out of scientific notation. That's not wrong, but that means that at the end, I'm gonna have to do extra work to then put it back into scientific notation, which will be kind of annoying. So I went ahead and left this one as a single digit in front of the decimal, and then made this one become like a 0 digit in front of the decimal, so that my final answer is still in scientific notation. So with that being said, on this next question, we do want to move left, because you've got -3 and -2. Move this, so you want this to go +1, left add, right subtract. So move this one to the left so that you can add 1, leaving this one to be the digit, the non-zero digit in front of the decimal. So go ahead and try a few of these, maybe 3 of them, and then check your answer on Canvas to see if you're getting the hang of it. Let me know if you have any questions, mark them up, and we'll discuss them in class. Now for multiplying and dividing, the steps are multiply and divide the numbers part, then use the product rule or the quotient rule to change the exponent of the tens, and then we're going to use left add, right subtract to adjust the decimal in the final answer as needed, because our final answer has to be in appropriate scientific notation, which means there's a single non-zero digit in front of the decimal point, right, times 10 to some number. So there's got to be one non-zero digit in front of the decimal point. So for 25, you will multiply 2.8 times 1.9, which if you do that computation, you'll get 5.32 times 10 to the 7 plus 4, because the product rule says a to the m times a to the n equals a to the m plus n. So the final answer would be 5.32 times 10 to the 11th power. So you again multiply the numbers. So you pull off to the side of your paper and multiply those decimals. And then you do the product rule, -2 plus 6 for this one. You do the product rule on the powers of 10. So 10 to the a times 10 to the b equals 10 to the a plus b. For the division, you will divide, so you will do 1.2 divided by 5. And for this particular problem, you get 0.24, that's 1.2 divided by 5. And that's multiplied by, let's do the quotient rule here, 10 to the top minus bottom. So that's 10 to the first power. But our final answer is not in appropriate scientific notation because that's not a non-zero digit in front of the decimal. So left add, right subtract. We're going to move this right one. So 2.4 times 10 to the 0 power. Left add, right subtract. And since I moved it right one, I subtract 1, and I get 2.4 times 10 to the 0 power. Last division one, again, you will divide 2.0, so 2 divided by 3.2, which if you do that division, either by calculator or paper pencil, you will get 0.625, and that's multiplied to 10 to the 6 minus 7, because top minus bottom, 10 to the a over 10 to the b equals 10 to the a minus b. So that's 0.625 times 10 to the 13th. Need to fix the scientific notation, so I'm going to move this to the right one. So I'm going to subtract 1. Left add, right subtract. So I would suggest you do some of these as well. Check your answers on Canvas. And now that you've gotten a layer of information, try a few, use the answers to push you in the right direction. Mark any questions, and we'll have a whole group student-led conversation tomorrow about these questions. Thanks for watching.